Okay, so let's talk about what happens to the table when we have a transformation. So here I have a transformed function g of x. I want to know what the table of g of x would look like. Notice that we are still starting with the same parent function. The parent function f of x equals x squared. So first I need a table for my parent function. Again, I'm going to make this table from -2 to 2. I like that because it puts my vertex right in the middle. So then I'm going to use this information to make the table for g of x. So here's how I'm going to do that. The vertical transformations are on the outside of the parentheses. So in this equation, I can see that I have a vertical transformation at right here. So it's +5, and then I'm multiplying by -2. So I'm going to take all of the vertical or y values for the parent function. I'm going to take all of them, I'm going to multiply by -2 and add 5 to get my new y values for g of x. So first I'm going to come here and take 4. So I have 4 times -2 plus 5. That's going to give me -3. Then I'm going to do 1 right here. 1 times -2 plus 5. And that will give me +3. Then right here I have 0 times -2 plus 5. That's going to be 5. Then right here I have 1. So I have, again, 1 times -2 plus 5, and that's going to give me 3 again. And then I have one more time, 4. So I have 4 times -2 plus 5. And that again will give me -3. And you can see that lovely symmetry that happened in the parent function is happening here. So notice this is my vertex for the parent function, and you can see that there's symmetry in the table here. This is where my vertex should be for the new function, and I should have that same symmetry in the table that I had in the parent function. So, let's see. Now, I need to do the horizontal transformations. The horizontal transformations happen inside the parentheses. So here inside the parentheses, you can see that we're taking the x value and we're multiplying, we're not multiplying, we're subtracting 2. So I'm going to take all of these horizontal values or x values and multiply by -2. So right here, you can see, so I have -2 minus 2. Is that right? Oh no, I want to add 2. Here's why I want to add 2. You might be saying to yourself, why would I do that? Well, remember that in the horizontal movement here, to subtract 2 in the parentheses means we need to go right 2. Well, in order for us to go right by 2, we need to add 2. So I'm going to add 2 to each of these x values. So -2 plus 2 is 0. I'm going to use this x value here. So -1 plus 2 is 1. Then I'll look at 0. I have 0 plus 2 is 2. And then I have 1 right here. So 1 plus 2 is 3. And then right here I have a 2. So I'm going to do 2 plus 2 is 4. This would be the table for g of x. Now you can quickly check that if you just put it in Desmos. So if you'd like to go ahead and check your work, this is how you would do that. So you just put it in Desmos, and I'm going to put that g of x function in Desmos. So it was -2 parentheses x minus 2 squared plus 5. And you can see right here, you can see these transformations. You can see that the vertex is at 2, 5. If you hit the table, you can see the table, you'll want to adjust it so it matches the x values that we have entered, which is 0, 1, 2, 3, and 4. And you can see that the Desmos table matches the table that I have here in the notes. All right, what's really great too is that this new table, you can see a lot of these transformations. So if I put in the parent function, you can compare that to the parent function. You can see that it is reflected over the x-axis. It's a little bit thinner because it has that vertical stretch. And the vertex has gone right 2 and up 5. So you can see that when you graph the parent function and the transformed function together. So let's look at another example, preferably an example with slightly more horizontal changes, because horizontal changes can be tricky. So example 8, let's look at g of x equals 1/2 x minus 4, that quantity is squared, plus 3. Now again, I'm going to compare that to the table for the parent function. So I'm just going to quickly make a table for the quadratic parent function. All right, and I'm going to set up my table for g of x, or the transformed function. Now, the vertical transformations in this are actually quite easy and quick. Okay, so you can see that there's only a plus 3. So since there's only a plus 3 here on the end, that's all I have to do to the y values is add 3. And that's a really, really fast go. So 4 plus 3 is 7. 1 plus 3 is 4. 0 plus 3 is 3. And then, of course, it should be reflected, because this is the vertex in our parent function, so that is where the vertex should be in our transformed function. Now I'm going to do some horizontal transformations. Now this is where life gets tricky. Remember, the horizontal transformations have to be factored, meaning everything in the parentheses has to be fully factored. So if I were to take these parentheses and fully factor them, I would have 1/2 times x minus 8. So this is a horizontal stretch by a factor of 2. And we're going to go right 8. Because of that, what I'm going to have to do to each of these x values is I'm going to have to multiply by 2 and then add 8. That's what I'm going to have to do to get each of my new x values. So I'm going to do that here on the side. So I'm going to take -2 here. So I have -2. I'm going to multiply that by 2 and add 8. So that's -4 plus 8 is 4. Okay. Then I'm going to go to -1. So I have -1 times 2 plus 8. That's -2 plus 8. That's 6. Then I have 0 times 2 plus 8. That's going to be 8. Then I'm going to go right here. I have 1. So 1 times 2 plus 8 is going to be 10. And then last but not least, number 2. So I have 2 times 2 plus 8. 4 plus 8 is 12. And that would be the table for g of x. And you can verify that by putting that into Desmos. So if I take the parent function, or not the parent, yes, I could do the parent function, but I'm going to take the transformed function we had there, which was parentheses 1/2 times x minus 4, and all of that was squared, plus 3. And you'll be able to see that graph here. You can see that the vertex is 8, 3. If you click on the table, go ahead and choose the x values that represent what we chose in our table. And you'll see that the table does match. The table in Desmos does match the table that we have here by hand. So let's do one more. One more. All right. Example 9. Example 9. So let's say we have g of x is equal to 3/5 x plus 1 squared minus 2. So first, take a minute and write down your parent function table. Then we're going to create a table for g of x. Now, take a minute and pause the video, see if you can make this table on your own. Feel free to use fractions. Fractions are our friends. Okay, let's do a quick double check. So I'm going to look at the y values, So I'm going to look at the vertical transformations. So I'm multiplying by 3/5 and then subtracting 2. And I'm going to do that to all of these numbers here. So what I would do is I would take 4 times 3/5 minus 2. And I got negative 2/5. Then I'm going to take 1. I have 1, not 4, 1. 1 times 3/5 minus 2. And I got negative 7/5. Then I'll do the same thing with 0. So I have 0 times 3/5 minus 2. And that would give me negative 2. And then I know that that's going to repeat. I'm not going to put it back in because I know that that's where my vertex was, so that's where I'm going to start a repeat. So now I just need to do the x values. The horizontal changes are going to happen in the parentheses, and this is a relatively easy horizontal change happening right here. So the horizontal change is that I'm going left 1. In order to go left 1, I need to subtract 1. And I need to subtract 1 from the x values, so from all of these right here. So that's what I'm going to do to get my new x values. So negative 2 minus 1 is negative 3. Negative 1 minus 1 is negative 2. 0 minus 1 is negative 1. 1 minus 1 is 0. 2 minus 1 is 1. And that is the table for g of x. See, it's even simple when there are fractions.